Today I'm going to go through the process of using Microsoft Excel to solve this problem. If you're in my class, you can see page 399 of your textbook. Now, we'll start by entering a few labels. We'll store the volume, 50,000, up here, ready for use. And then we'll come down a bit and we'll go radius. Now let's start with a radius of 1. And let's create a formula where we use the previous value of radius and then we add 1. Then we will copy that down a few extra rows. That'll do for now, maybe one more. Now I want the height of my cylinder. So I'll use this version of the formula. So that came from our volume formula, rearranged, and we put our 50,000 value. So we go equals. Now, instead of typing 50,000, I'll get hold of the cell value by clicking there. And I want to put a $sign in front of the 1 to stop that from changing when I copy the formula down. I divide by. Now I open brackets, I go pi. In Excel, we have to type pi, then 2 more brackets, multiplied by the radius, which is here, squared to the power 2. Close the brackets. Now I'm happy that the A5 doesn't have $signs. When I copy that, I want it to change to A6 on the next one down, and so on. And we'll copy them down. There we go. So that's the height of the different cylinders. You'll remember when we did one manually in class, we checked the height. If we had a 10 centimeter radius, that matches our answer. We checked that one as well, it matches. So our formula seems to be working. Now let's work out the surface area. Again, start with an equals key, and our formula this time is over here. So we've got to translate that. 2 times pi, remember the brackets, times the radius is here, squared, plus 2 times pi times radius times height. Don't worry about the orange. And there we go. Now, we can see as we go to larger radii, the surface area seems to be getting smaller. I wonder if it continues to get smaller. Let's copy these few cells down a little bit more. No, it doesn't. As we go past, we go from 713 up to 7,532. It's going back up again. So that one at 20 centimeters is the radius. That gives the smallest surface area. Now, we got a little bit fancier. Instead of automatically going up in steps of 1, we decided we would create a place to store the step value. Let's go 0.1. Now the first one I'm typing in myself. This is where the formula is. So instead of 1, I'll click on cell B2 and I'll put a $sign to make sure that the B2 value stays fixed. A5 changes to A6 to A7 as we go down, but B2, it's always going back and adding on 0.1. So let's copy those down. And now I'm going from 1 to 3.4. Now we thought the answer was about 20-ish, didn't we? So let's start from 19, going in steps of 0.1, and there's our answer at 20 again, which is the smallest. We could change the step size to 0.01, and this time I'm not going far enough. I might need to start at 19.8. Now coming up in steps of 0.01, that's actually a different radius. 20 was close, but our previous estimates were to the nearest 1 or to the nearest 0.1. To the nearest 0.01, it looks like the best radius is 19.6. And that's how we did that. If I click and drag on the first column, then holding the control key, I click and drag on the second column. I can then go Insert, Chart, and I'll have a scatter chart. And that shows me a nice diagram here. Now let's add some titles to the axis. The vertical value is the surface area. That's in the unit of square centimetres. The horizontal axis is the radius in centimetres. And the whole thing, this is a 50 litre cylinder is what this is all about. And so this tells me at different radii the surface area. And the thing in common, it's all 50 litre cylinders. So if you can follow through that, you'll be able to build your own spreadsheet. Thanks for watching.